Question 1. Stakeholder feedback indicates that the performance of a critical application is being negatively impacted by index contention on a DB2 for Z/OS subsystem, leading to user complaints about slow response times. The application team is requesting an immediate resolution, suggesting the possibility of disabling referential integrity checks on certain tables to alleviate the contention. As the DB2 for Z/OS DBA, what is the most appropriate course of action to address this situation while adhering to best practices and regulatory considerations? Option A. Analyze the index contention and performance metrics. Develop a plan to test alternative indexing strategies or index reorganizations in a non-production environment, and then implement the validated solution through the established change control process. Option B. Advise the application team to proceed with disabling referential integrity checks on the affected tables, as their feedback is the primary driver for performance improvement. Option C. Implement a solution using an undocumented third-party utility that claims to optimize index performance without extensive testing to quickly resolve the stakeholder concerns. Option D. Immediately disable referential integrity checks on the affected tables in the production environment to provide immediate relief to the application team and address the performance issue. Correct answer is A. Analyze the index contention and performance metrics. Develop a plan to test alternative indexing strategies or index reorganizations in a non-production environment, and then implement the validated solution through the established change control process. Explanation. Scenario analysis. This scenario is professionally challenging because it requires the DBA to balance the immediate need for application availability with the long-term integrity and performance of the DB2 for Z/OS subsystem. Stakeholder feedback, while valuable, can sometimes be driven by short-term pressures that might conflict with robust operational practices. The DBA must exercise sound judgment to ensure that any proposed solution adheres to established best practices and regulatory compliance without compromising data integrity or system stability. Correct approach analysis. The correct approach represents best professional practice because it prioritizes a thorough, controlled, and documented process for implementing changes. This aligns with the principles of good governance and operational excellence expected in a regulated environment. Specifically, it ensures that any change to the DB2 for Z/OS subsystem, especially one impacting critical data structures like indexes, is evaluated for its potential impact on performance, security, and recoverability. The emphasis on testing in a non-production environment before deployment to production is a fundamental tenet of risk management. Furthermore, adherence to established change control procedures and documentation requirements is often mandated by internal policies and external regulations to ensure auditability and accountability. This methodical approach minimizes the risk of unintended consequences and ensures that the change is implemented in a manner that is both effective and compliant. Incorrect approaches analysis. Implementing the change directly in the production environment without prior testing or proper change control is a significant regulatory and ethical failure. This bypasses essential risk mitigation steps, increasing the likelihood of system outages, data corruption, or performance degradation. Such an action would violate principles of due diligence and could lead to non-compliance with internal service level agreements, SLAs, and potentially external data protection regulations if data integrity is compromised. It demonstrates a lack of professional responsibility and a disregard for the stability of the critical business systems. Proposing a solution that involves disabling referential integrity checks without a clear understanding of the downstream implications is also professionally unacceptable. Referential integrity is a cornerstone of relational database design, ensuring data consistency and accuracy. Disabling it, even temporarily, introduces a high risk of orphan records and data anomalies. This action would likely contravene data quality standards and could lead to reporting inaccuracies and business process failures, potentially violating regulations that mandate accurate record keeping. Suggesting a solution that relies on undocumented or unsupported third-party tools without rigorous validation is another failure. Such tools may not be compatible with the specific version of DB2 for Z/OS or the Z/OS operating system, leading to unpredictable behavior, security vulnerabilities, or performance issues. Relying on unvetted solutions can expose the organization to significant risks and would likely be considered a breach of professional duty to ensure the integrity and security of the data and the system. Professional reasoning. Professionals should adopt a structured decision-making process that begins with a clear understanding of the problem and its impact. This involves gathering all relevant information, including stakeholder feedback, system logs, and performance metrics. The next step is to identify potential solutions, evaluating each against established best practices, technical feasibility, and regulatory requirements. A critical phase is risk assessment, where the potential negative impacts of each solution are analyzed. Prioritizing solutions that involve testing in a controlled environment, adhering to change management processes, and ensuring data integrity is paramount. Documentation and communication with stakeholders throughout the process are essential for transparency and accountability. Question 2. Implementation of a strategy to provide realistic data for DB2 for Z/OS application development and testing environments, while ensuring the protection of sensitive production data and adherence to relevant U.S. data privacy regulations, requires careful consideration of several approaches. Which of the following best represents a compliant and effective solution? Option A. Limiting testing to extremely small, non-representative subsets of production data with no sensitive information included. Option B. Utilizing entirely synthetic data that does not replicate the volume or complexity of actual production data. Option C. Granting unrestricted read access to the production DB2 for Z/OS database for all development and testing activities. Option D. Masking or anonymizing sensitive data fields in copies of production data before loading them into development and testing environments. Correct answer is D. Masking or anonymizing sensitive data fields in copies of production data before loading them into development and testing environments. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing the need for robust data security and integrity with the operational demands of application development and testing. The core conflict lies in providing developers with access to realistic data for testing without compromising sensitive production information or violating regulatory compliance. The professional challenge is to implement a solution that satisfies both technical requirements and strict data governance mandates. Correct approach analysis. The correct approach involves implementing a robust data masking and anonymization strategy for non-production environments. This aligns with the principles of data privacy and security mandated by regulatory frameworks applicable to data handling, such as those that might govern financial or healthcare data in a U.S. context. By masking or anonymizing sensitive fields, e.g., personally identifiable information, financial account numbers, in copies of production data used for development and testing, the DBA ensures that developers can work with realistic data structures and volumes without exposing actual sensitive information. This practice is crucial for preventing data breaches, maintaining customer trust, and adhering to compliance requirements that penalize unauthorized data exposure. It demonstrates a proactive stance on data protection, a key responsibility for a DBA. Incorrect approaches analysis. Providing direct, unfiltered access to production data for development and testing environments is a severe regulatory and ethical failure. This approach directly violates data privacy regulations, which typically mandate the protection of sensitive information. It exposes the organization to significant risks of data breaches, identity theft, and financial fraud, leading to substantial fines, legal repercussions, and reputational damage. Such a practice demonstrates a disregard for data governance and security best practices. Using synthetic data that does not accurately reflect the volume, variety, or complexity of production data can also be problematic, though less severe than direct production access. While it offers a degree of security, it can lead to incomplete or inaccurate testing results. This might cause defects to be missed during the development cycle, potentially impacting application functionality and user experience in production. From a regulatory perspective, if the application handles sensitive data, testing with inadequate data representations might mean that compliance controls are not adequately validated, leading to potential future noncompliance. Restricting all access to production data and only allowing testing with extremely limited, non-representative sample data is also an incorrect approach. While it prioritizes security, it severely hampers the effectiveness of the development and testing process. Developers cannot adequately test application logic, performance, or data integrity with such limited datasets. This can result in the deployment of applications with latent defects that may only surface under production load or with more realistic data, potentially leading to operational disruptions, and, in regulated industries, compliance issues if the application's integrity is compromised. Professional reasoning. Professionals should approach this challenge by first understanding the specific data sensitivity classifications and the applicable regulatory requirements, e.g., SOX, HIPAA, PCI DSS in a U.S. context. A risk-based assessment should then guide the selection of appropriate data protection techniques. The decision-making process should involve collaboration with security teams, application development leads, and compliance officers to ensure a balanced solution that meets security, privacy, and operational needs. Prioritizing data masking and anonymization for non-production environments, coupled with strict access controls and auditing, represents a mature and compliant approach to data management. Question 3. Cost-benefit analysis shows that decommissioning a legacy DB2 for Z/OS application could yield significant cost savings, but a DBA must ensure that this process adheres to all applicable regulatory frameworks and maintains data integrity. Which approach best balances these competing priorities while upholding professional and regulatory obligations? Option A. Proceed with decommissioning immediately to realize cost savings, assuming that the low reported usage of the application implies minimal critical data. Option B. Decommission the application without a detailed data dependency analysis, relying on existing documentation which may be outdated. Option C. Migrate all data from the legacy application to a new system without validating the new system's compliance with relevant Z/OS security and data governance standards. Option D. Conduct a comprehensive data dependency analysis. Develop a phased migration or archival strategy with clear validation checkpoints against regulatory requirements, and perform a thorough risk assessment before final decommissioning. The correct answer is D. Conduct a comprehensive data dependency analysis. Develop a phased migration or archival strategy with clear validation checkpoints against regulatory requirements, and perform a thorough risk assessment before final decommissioning. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing the immediate cost savings of decommissioning a legacy application with the potential long-term risks and compliance implications. The challenge lies in accurately assessing the true cost of maintaining the old system versus the potential costs of data loss, regulatory noncompliance, and operational disruption if the decommissioning is mishandled. A DBA must consider not just direct financial costs, but also indirect costs related to security, auditability, and business continuity, all within the strict regulatory environment of Z/OS environments. Correct approach analysis. The correct approach involves a comprehensive risk assessment and a phased migration strategy. This aligns with best practices for data management and regulatory compliance in Z/OS. Specifically, it emphasizes understanding data dependencies, ensuring data integrity during migration, and validating the new system against regulatory requirements before fully decommissioning the old one. This proactive approach minimizes the risk of data loss, ensures continued compliance with relevant regulations, e.g., data privacy, financial reporting standards applicable to the Z/OS environment, and safeguards business operations. It demonstrates due diligence and a commitment to responsible data lifecycle management, which are critical for maintaining trust and avoiding penalties. Incorrect approaches analysis. Decommissioning without a thorough data dependency analysis is a significant regulatory and ethical failure. It risks leaving critical data inaccessible or corrupted, violating data retention policies, and potentially leading to noncompliance with audit requirements. This approach prioritizes short-term cost savings over long-term data integrity and regulatory adherence. Migrating data without validating the new system's compliance with relevant Z/OS security and data governance standards is another critical failure. This could result in the new system being vulnerable to breaches or failing to meet reporting obligations, leading to severe regulatory penalties and reputational damage. It neglects the fundamental responsibility of ensuring data is handled securely and compliantly throughout its lifecycle. proceeding with decommissioning solely based on the perceived low usage of the legacy application, without a formal risk assessment or a clear data archival strategy, is professionally unsound. This overlooks potential hidden dependencies or critical historical data that might be required for future audits or legal discovery, thereby risking non-compliance with data retention and discovery regulations. Professional reasoning. Professionals should adopt a structured decision-making process that begins with a thorough understanding of the business and regulatory context. This involves identifying all stakeholders, understanding their requirements, and assessing potential risks and benefits. For data decommissioning, this means conducting a detailed data inventory, analyzing dependencies, performing a risk assessment that considers regulatory implications, and developing a phased migration or archival plan. Continuous monitoring and validation throughout the process are essential. This systematic approach ensures that decisions are informed, defensible, and aligned with both business objectives and regulatory mandates, fostering a culture of responsible data stewardship. Question 4. Compliance review shows that the organization's DB2 for Z/OS environment may not be adequately logging all data access and modification events for sensitive customer information, potentially violating regulatory requirements for audit trails. As the lead DBA, what is the most appropriate course of action to ensure full compliance while minimizing disruption to ongoing business operations? Option A. Manually script the capture of specific data access events for sensitive tables and store these logs on a separate, less secure server for cost savings. Option B. Implement comprehensive auditing for all DB2 objects containing sensitive data, prioritizing critical tables and ensuring audit logs are securely stored and retained according to regulatory mandates. Option C. Focus solely on optimizing query performance and data retrieval speeds, assuming that existing, less granular logging is sufficient for compliance. Option D. Disable all auditing features to improve DB2 performance, relying on application-level logging for any necessary tracking. The correct answer is B. Implement comprehensive auditing for all DB2 objects containing sensitive data, prioritizing critical tables and ensuring audit logs are securely stored and retained according to regulatory mandates. Explanation. This scenario presents a professional challenge because the DBA is tasked with ensuring data integrity and availability for critical business operations, while simultaneously adhering to stringent regulatory requirements for data retention and access logging. The challenge lies in balancing performance optimization with the overhead introduced by comprehensive auditing, which can impact system resources and user experience. The DBA must make informed decisions that satisfy both technical and compliance mandates. The correct approach represents best professional practice because it directly addresses the regulatory mandate for audit trail maintenance without compromising the core function of the database. By implementing a phased approach, starting with critical objects and gradually expanding, the DBA demonstrates a pragmatic and risk-based strategy. This ensures that the most sensitive data is protected and auditable first, aligning with the principle of least privilege and minimizing immediate performance impact. The use of DB2 built-in auditing features, configured according to regulatory guidelines, is the most direct and compliant method. This approach prioritizes regulatory adherence by ensuring that all required access and modification events are captured and retained, providing a clear audit trail for compliance purposes. An incorrect approach that focuses solely on performance optimization without considering audit requirements would be a significant regulatory failure. This would violate the principle of accountability and transparency mandated by regulations, as it would leave the organization vulnerable to undetected unauthorized access or data manipulation. Another incorrect approach, such as disabling auditing entirely to improve performance, represents a direct contravention of regulatory frameworks that mandate data access logging. This failure would expose the organization to severe penalties, reputational damage, and loss of trust. A third incorrect approach, which involves manual log file management without proper retention policies or security controls, introduces significant risks of data loss, tampering, and noncompliance with retention periods, failing to provide a reliable and auditable record. The professional reasoning process for this situation involves a thorough understanding of the applicable regulatory framework for data management and auditing within the Z/OS environment. the DBA should first identify all relevant regulations and their specific requirements regarding data access logging, retention, and security. Next, they should assess the current DB2 configuration and identify any gaps in meeting these requirements. A risk assessment should then be performed to prioritize the implementation of auditing controls, focusing on critical data and high-risk operations. Finally, the DBA should select and configure DB2 auditing features in a manner that balances compliance needs with system performance and operational efficiency, documenting all decisions and configurations for audit purposes. Question 5. Operational review demonstrates a potential for significant performance improvement by adjusting specific DB210 for Z/OS subsystem parameters. The proposed adjustments have been documented, but a dedicated testing environment that perfectly mirrors the production workload is not readily available. The urgency to realize these performance gains is high, as they are expected to directly impact critical business reporting cycles. Which approach best balances the need for performance improvement with the imperative of maintaining data integrity and system stability? Option A. Implement the parameter changes in a separate, non-production environment that closely approximates production, even if it cannot perfectly replicate the entire workload, followed by a controlled production deployment with rollback capabilities. Option B. Apply the parameter changes only during a scheduled, extended maintenance window, assuming that the lack of immediate issues indicates successful implementation. Option C. Implement the parameter changes directly in the production environment during a low-activity period, relying on application logs for post-implementation verification. Option D. Conduct a phased rollout of the parameter changes, starting with a subset of the production workload and closely monitoring key performance indicators and data integrity metrics with a predefined rollback plan. The correct answer is C. Implement the parameter changes directly in the production environment during a low-activity period, relying on application logs for post-implementation verification. Explanation: Scenario analysis. This scenario presents a common challenge for DB210 for Z/OS DBAs, balancing performance optimization with the need for robust data integrity and adherence to established operational procedures. The pressure to deliver immediate performance gains can tempt the DBA to bypass standard testing protocols. The professional challenge lies in resisting this pressure and prioritizing long-term system stability and compliance over short-term expediency. The risk of introducing subtle, hard-to-diagnose issues that could impact critical business operations necessitates a rigorous, methodical approach. Correct approach analysis. The correct approach involves a phased implementation strategy that includes thorough testing in a non-production environment, followed by a controlled rollout with rollback capabilities. This aligns with best practices for system administration and data management, emphasizing risk mitigation and ensuring that changes do not negatively impact data integrity or application functionality. Specifically, this approach adheres to the principles of change management, which are implicitly or explicitly mandated by operational guidelines and often by regulatory compliance frameworks that require auditable and controlled system modifications. The emphasis on testing in a representative environment ensures that potential issues are identified and resolved before affecting production data, thereby upholding the DBA's responsibility for data integrity and system availability. Incorrect approach is analysis. Implementing the change directly in the production environment without prior testing is a significant regulatory and ethical failure. It violates fundamental principles of change management, which are designed to prevent unintended consequences and ensure system stability. This approach exposes the organization to unacceptable risks of data corruption, application downtime, and potential financial or reputational damage. Demonstrates a disregard for due diligence and professional responsibility. Applying the change only during a scheduled maintenance window without comprehensive testing in a separate environment is also professionally unacceptable. While a maintenance window offers a controlled period for deployment, it does not mitigate the risk of introducing errors if the change has not been validated. The lack of pre-production testing means that unforeseen issues could still arise, potentially extending the maintenance window or causing unexpected outages. This approach still prioritizes speed over certainty, which is contrary to the principles of robust system management. Performing the change in production and relying solely on application logs for post-implementation verification is a flawed strategy. Application logs can provide some insight, but they are not a substitute for dedicated database testing. Critical data integrity issues or performance regressions might not be immediately apparent in application logs, or the logs themselves might be incomplete or misleading. This approach lacks the proactive validation necessary to ensure the integrity and performance of the DB2 subsystem. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes risk assessment and mitigation. This involves 1. Understanding the proposed change and its potential impact. 2. Identifying all relevant operational procedures and compliance requirements. 3. Evaluating the risks associated with different implementation strategies. 4. Selecting the strategy that minimizes risk while achieving the desired outcome, typically involving thorough testing in a controlled environment before production deployment. 5. Establishing clear rollback procedures. This systematic approach ensures that decisions are defensible, align with professional standards, and protect the integrity of the data and the stability of the system. Question 6. Investigation of a critical performance degradation in a production DB210 for Z/OS subsystem prompts a developer to request an immediate, undocumented modification to a critical control file, bypassing the standard change management process. The developer asserts this is the only way to resolve the issue before a major business deadline. What is the most professionally responsible course of action for the DB2 for Z/OS DBA? Option A. Refuse the immediate modification and insist on following the established change control procedures, including impact analysis, testing in a non-production environment, and formal approval, while offering to expedite the review process. Option B. Advise the developer on how to make the modification themselves to save time, as the DBA is not directly responsible for application-level tuning. Option C. Immediately escalate the issue to senior management, highlighting the developer's request and the potential business impact of not complying. Option D. Implement the requested modification directly in the production environment to meet the business deadline, documenting the change retrospectively. The correct answer is A. Refuse the immediate modification and insist on following the established change control procedures, including impact analysis, testing in a non-production environment, and formal approval, while offering to expedite the review process. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing performance optimization with data integrity and adherence to established operational procedures. The DBA is faced with a request to implement a change that could significantly impact system performance, but the proposed method bypasses standard change control and testing protocols. This creates a professional dilemma, as the DBA must weigh the potential benefits of immediate performance improvement against the risks of introducing instability, data corruption, or security vulnerabilities without proper vetting. The pressure to deliver rapid results can conflict with the fundamental responsibility of maintaining a stable and secure database environment. Correct approach analysis. The correct approach emphasizes a structured, risk-mitigated process that aligns with best practices for database administration and IT governance. This involves thoroughly understanding the proposed change, its potential impact, and the underlying reasons for the performance issue. It necessitates engaging with the requester to explore alternative solutions that can be implemented through established channels. Crucially, it requires adherence to the organization's change management policy, including proper documentation, impact assessment, testing in a non-production environment, and obtaining necessary approvals before any production deployment. This approach upholds the DBA's professional responsibility to ensure the integrity, security, and availability of the DB2 subsystem, minimizing the risk of unintended consequences and demonstrating due diligence. It reflects a commitment to operational excellence and regulatory compliance by following documented procedures designed to protect the data and the system. Incorrect approaches analysis. Implementing the change directly in the production environment without proper testing or approval represents a significant regulatory and ethical failure. This bypasses established change control procedures, which are often mandated by internal policies and potentially external compliance requirements, e.g., SOX, GDPR, depending on the industry and data handled. Such an action introduces a high risk of system instability, data corruption, or security breaches, which could lead to financial losses, reputational damage, and legal repercussions. Demonstrates a disregard for the established governance framework and a failure to uphold the professional duty of care. Suggesting a quick fix without fully understanding the root cause of the performance issue is also professionally unsound. While seemingly proactive, it risks addressing symptoms rather than the underlying problem, potentially leading to recurring issues or masking more serious underlying defects. This approach lacks the analytical rigor expected of a DBA and could result in wasted effort or the implementation of suboptimal solutions. It fails to demonstrate a commitment to a comprehensive and sustainable resolution. Escalating the issue to management without attempting to understand the request or explore potential solutions first can be seen as an abdication of responsibility. While escalation is sometimes necessary, it should be a last resort after reasonable due diligence has been performed. This approach might be perceived as a lack of initiative or an unwillingness to engage with technical challenges, potentially hindering effective problem solving. Professional reasoning. Professionals facing such situations should employ a decision-making framework that prioritizes risk assessment and adherence to established protocols. This involves 1. Understanding the request. Clearly define the problem and the proposed solution. 2. Impact assessment. Evaluate the potential technical, operational, and business impacts of the proposed change. 3. Root cause analysis. Investigate the underlying reasons for the performance issue. 4. Solution exploration. Identify and evaluate alternative solutions, including those that align with standard procedures. 5. Risk mitigation. Develop strategies to minimize identified risks. 6. Communication. Engage with stakeholders, including the requester and relevant IT governance bodies. 7. Documentation. Maintain thorough records of the problem, proposed solutions, assessments, and decisions. 8. Adherence to policy. Strictly follow organizational change management and operational procedures. 9. Decision and justification. Make a reasoned decision based on the assessment and be prepared to justify it. Question 7. What factors determine the optimal strategy for implementing a data archiving solution in DB2 for Z/OS, considering both operational efficiency and regulatory compliance? Option A. A comprehensive analysis of data access patterns, regulatory retention mandates, and business requirements for historical data retrieval. Option B. Prioritizing cost reduction in the archiving solution above all other considerations, including data retrieval performance. Option C. Archiving data solely based on its age, irrespective of its current business value or access frequency. Option D. Archiving data based on perceived business value without adherence to specific regulatory retention periods. The correct answer is A. A comprehensive analysis of data access patterns, regulatory retention mandates, and business requirements for historical data retrieval. Explanation. Scenario analysis. A DB2 for Z/OS DBA is tasked with implementing a new data archiving strategy. This strategy involves identifying and migrating historical data from active DB2 tables to a separate, cost-effective storage solution. The challenge lies in balancing the need for efficient data retrieval for compliance and historical analysis against the costs associated with storage, performance impact on active systems, and the complexity of managing a tiered data environment. The DBA must consider not only technical feasibility, but also the potential business impact, regulatory requirements for data retention, and the long-term maintainability of the solution. This scenario is professionally challenging because it requires a holistic view, integrating technical expertise with business objectives and regulatory compliance, all while managing resource constraints. Correct approach analysis. The correct approach involves a comprehensive assessment of data usage patterns, regulatory retention mandates, and business requirements for historical data access. This includes analyzing query frequency, data sensitivity, and the cost-benefit of different archiving technologies and methodologies. The DBA should collaborate with business stakeholders, compliance officers, and system architects to define clear criteria for data eligibility for archiving, establish retention periods aligned with legal and business needs, and select an archiving solution that minimizes performance impact on production systems while ensuring data integrity and accessibility. This approach represents best professional practice because it is data-driven, stakeholder-aligned, and risk-aware, ensuring that the archiving strategy supports business goals, meets regulatory obligations, and is technically sound and cost-effective. It adheres to the principles of responsible data management and governance. Incorrect approaches analysis. Archiving data solely based on age without considering access frequency or business value is professionally unacceptable. This approach fails to meet the core objective of efficient data management, potentially leading to the archiving of frequently accessed critical data, thereby impacting performance and increasing retrieval costs. It also risks archiving data that is no longer required by regulations, leading to unnecessary storage costs and compliance risks. Implementing an archiving solution that prioritizes cost reduction above all else, without adequate consideration for data retrieval performance or regulatory compliance, is also professionally unsound. This can result in a system where historical data is inaccessible or takes an unacceptably long time to retrieve, hindering business operations and potentially violating data access requirements mandated by regulations. Ignoring regulatory retention requirements and archiving data based purely on perceived business value is a significant ethical and regulatory failure. This can lead to noncompliance with legal obligations, resulting in severe penalties, reputational damage, and legal liabilities. It demonstrates a lack of due diligence and a disregard for the organization's legal responsibilities. Professional reasoning. Professionals should employ a structured decision-making framework that begins with understanding the problem context and identifying all relevant constraints and objectives. This involves gathering information from all affected parties, including business users, compliance teams, and IT operations. The next step is to identify and evaluate potential solutions against defined criteria, which should encompass technical feasibility, cost-effectiveness, performance impact, security, and regulatory compliance. A thorough risk assessment should be conducted for each viable option. The chosen solution should be the one that best balances these factors, with a clear justification documented. Regular review and adaptation of the strategy are also crucial to ensure its continued effectiveness and compliance. Question 8. When evaluating a critical DB2 for Z/OS database outage and under significant pressure to restore service, which of the following approaches best balances immediate recovery needs with long-term data integrity and regulatory compliance? Option A. Engage the incident response team to follow the documented disaster recovery plan, which includes assessing the extent of data loss, performing a controlled restore, and validating data integrity before bringing the database back online. Option B. Attempt to manually correct the database inconsistencies by directly manipulating system logs and control files, as this is the fastest way to bring the system back online without external dependencies. Option C. Immediately initiate a full restore from the most recent full backup, bypassing standard change control for expedited restoration, and document the actions taken post-recovery. Option D. Restore from an older backup that is known to be stable, even if it means significant data loss, to ensure the system is operational as quickly as possible. The correct answer is C. Immediately initiate a full restore from the most recent full backup, bypassing standard change control for expedited restoration, and document the actions taken post-recovery. Explanation. This scenario presents a professional challenge because the DBA must balance the immediate need for system availability with the long-term integrity and security of the DB2 for Z/OS environment. The pressure to restore service quickly can lead to shortcuts that violate established procedures and potentially compromise data. Careful judgment is required to ensure that any recovery action is both effective and compliant with internal policies and external regulations. The correct approach represents best professional practice because it prioritizes a systematic and documented recovery process. This aligns with the principles of good governance and auditability, which are often mandated by regulatory frameworks governing data management and financial systems. By adhering to established recovery procedures, the DBA ensures that the recovery is performed in a controlled manner, minimizing the risk of further data corruption or security breaches. This methodical approach also facilitates post-incident analysis, allowing for improvements to future disaster recovery plans. An incorrect approach that bypasses standard change control procedures and directly manipulates system logs without proper authorization is professionally unacceptable. This failure constitutes a direct violation of internal controls and potentially regulatory requirements for data integrity and audit trails. Such actions can lead to an inability to reconstruct the sequence of events, making it impossible to satisfy audit requests or prove compliance. Furthermore, Unauthorized system modifications increase the risk of introducing new errors or security vulnerabilities, exacerbating the initial problem. Another incorrect approach that involves restoring from an older backup without thoroughly assessing the data loss and potential impact on dependent applications is also professionally unsound. This demonstrates a lack of due diligence and a failure to consider the broader business implications of the recovery. It can lead to significant operational disruption, financial losses, and reputational damage if critical data is permanently lost or if applications become inconsistent. This approach neglects the responsibility to minimize business impact, a core tenet of IT service management. The professional reasoning framework that should be applied in such situations involves a multi-step decision-making process. First, assess the full scope and impact of the incident. Second, consult and adhere to established disaster recovery and business continuity plans. Third, document all actions taken, including any deviations from standard procedures, with clear justifications. Fourth, communicate effectively with stakeholders regarding the incident, recovery progress, and expected resolution. Finally, conduct a thorough post-incident review to identify lessons learned and implement preventative measures. This structured approach ensures that decisions are informed, defensible, and aligned with organizational objectives and regulatory obligations. Question 9. Strategic planning requires a DBA responsible for DB2 for Z/OS to evaluate a proposed performance tuning strategy that promises significant speed enhancements but carries inherent risks to data integrity and system availability. Which of the following approaches best balances these competing priorities while adhering to regulatory expectations for financial data systems? Option A. Conduct comprehensive testing of the tuning strategy in a non-production environment, develop detailed documentation and a rollback plan, and implement the changes in a phased manner with continuous monitoring. Option B. Prioritize achieving the highest possible performance metrics, deferring any concerns about potential impacts on data integrity or availability until after the changes are live. Option C. Implement the new tuning strategy directly into the production environment to realize performance gains as quickly as possible, assuming the risks are manageable. Option D. Proceed with the tuning strategy implementation only after receiving explicit, written approval from senior management, without conducting independent technical risk assessments. The correct answer is A. Conduct comprehensive testing of the tuning strategy in a non-production environment, develop detailed documentation and a rollback plan, and implement the changes in a phased manner with continuous monitoring. Explanation. Scenario analysis. A DBA for DB2 for Z/OS faces a critical decision regarding the implementation of a new performance tuning strategy. This strategy, while promising significant improvements, involves modifying core system parameters that could impact data integrity and availability. The challenge lies in balancing the pursuit of enhanced performance against the paramount responsibility of safeguarding data and ensuring uninterrupted service, all within the strict regulatory environment governing financial data processing. The DBA must navigate potential conflicts between business demands for speed and regulatory mandates for security and reliability. Correct approach analysis. The correct approach involves a phased, risk-mitigated implementation. This aligns with best practices for system administration and regulatory compliance in the Z/OS environment. Specifically, it adheres to the principles of change management and disaster recovery planning, which are often implicitly or explicitly required by financial regulations. By conducting thorough testing in a non-production environment, documenting all changes, and having a rollback plan, the DBA demonstrates due diligence. This proactive approach minimizes the risk of data corruption or service disruption, thereby upholding the regulatory obligation to maintain data integrity and availability. The focus on controlled deployment ensures that any unforeseen issues can be identified and addressed before impacting production systems, a critical aspect of responsible data management. Correct approach is analysis. Implementing the new tuning strategy directly in the production environment without prior testing or a rollback plan represents a significant regulatory and ethical failure. This approach disregards the fundamental principle of data integrity and availability, which are non-negotiable under financial regulations. Such an action could lead to data loss, system downtime, and severe financial penalties, as well as reputational damage. It demonstrates a lack of professional responsibility and a failure to adhere to established IT governance frameworks. Implementing the tuning strategy only after receiving explicit, written approval from senior management, without any independent technical validation or risk assessment, is also problematic. While management approval is important, it does not absolve the DBA of their technical responsibility. This approach outsources the risk assessment to non-technical personnel, potentially leading to decisions that are not technically sound or do not adequately address the inherent risks. It bypasses crucial steps in a responsible change management process, which is often a regulatory expectation for critical systems. Ignoring the potential impact on data integrity and focusing solely on achieving the highest possible performance metrics is a direct violation of regulatory requirements. Financial data systems are subject to stringent rules regarding accuracy, completeness, and accessibility. Prioritizing performance above these core tenets is not only unprofessional, but also illegal in many jurisdictions. This approach demonstrates a severe misunderstanding of the DBA's role and the critical importance of data governance. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes risk assessment and adherence to established governance and regulatory requirements. This involves 1. Understanding the business objective and its potential impact. 2. Identifying all relevant regulatory and compliance obligations. 3. Conducting a thorough technical assessment of proposed changes, including potential risks and benefits. 4. Developing a detailed implementation plan that includes testing, documentation, and rollback procedures. 5. Seeking appropriate approvals based on the risk assessment. 6. Executing the plan in a controlled manner with continuous monitoring. 7. Post-implementation review and documentation. This systematic approach ensures that decisions are informed, responsible, and compliant. Question 10. Benchmark analysis indicates that a proposed parameter change in DB2 for Z/OS could significantly improve query performance. However, the change has not been thoroughly tested in a production-like environment, and there is limited documentation on its long-term stability implications. As the lead DBA, what is the most professionally responsible course of action? Option A. Apply the change to a small subset of production systems to gauge its impact before a full rollout, accepting the inherent risks associated with testing in a live environment. Option B. Defer the implementation indefinitely due to the lack of complete documentation and the potential for unforeseen issues, prioritizing absolute stability over potential performance gains. Option C. Conduct a comprehensive testing and validation process in a non-production environment that closely mirrors production, including performance benchmarking and rollback planning, before considering a production rollout. Option D. Implement the parameter change directly in the production environment to realize the performance benefits immediately, as the potential gains are substantial. The correct answer is D. Implement the parameter change directly in the production environment to realize the performance benefits immediately, as the potential gains are substantial. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing performance optimization with the need for robust data integrity and adherence to established operational procedures. The challenge lies in the potential for performance gains versus the risk of introducing instability or violating change control policies, which are critical for maintaining a regulated production environment. The DBA must exercise sound judgment to assess the risk-reward profile of the proposed change. Correct approach analysis. The correct approach involves a thorough, phased testing and validation process before implementing any change in the production environment. This aligns with best professional practices and regulatory expectations for data management systems. Specifically, it emphasizes 1. Risk assessment, evaluating the potential impact of the change on performance, stability, and data integrity. 2. Controlled testing, implementing the change in a non-production environment, development, test, or staging that closely mirrors production. This allows for observation of behavior under realistic load conditions. 3. Performance benchmarking, measuring key performance indicators, KPI, before and after the change in the test environment to quantify the actual impact. 4. Rollback planning, developing a clear and tested procedure to revert the change if issues arise in production. 5. Change control adherence, following established change management procedures, which typically require documented testing, approval, and scheduled implementation windows. This methodical approach ensures that any performance improvements are validated, potential negative side effects are identified and mitigated, and the integrity of the production data is preserved, all while adhering to governance frameworks that often mandate controlled changes to critical systems. Incorrect approach is analysis. Implementing the change directly in production without adequate testing is a significant regulatory and ethical failure. This bypasses essential safeguards and exposes the organization to unacceptable risks. One incorrect approach is to immediately apply the change to the production environment based solely on theoretical benefits or anecdotal evidence from a limited, non-representative test. This demonstrates a disregard for due diligence and a failure to adhere to change management protocols. The regulatory failure here is the potential for data corruption, system downtime, or performance degradation that could impact business operations and violate service-level agreements, SLAs. Ethically, it represents a breach of professional responsibility to protect the integrity and availability of the data. Another incorrect approach is to postpone the implementation indefinitely due to minor, unquantifiable risks without attempting any form of controlled validation. While caution is important, an inability to assess and manage risks effectively can lead to missed opportunities for optimization and potentially hinder the system's ability to meet evolving business needs. This can be seen as a failure to proactively manage the system's health and efficiency, which, in a regulated environment, could indirectly lead to compliance issues if performance bottlenecks impact reporting or operational processes. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes risk management and adherence to established governance. This framework includes 1. Problem identification, clearly defining the issue or opportunity, e.g., potential performance improvement. 2. Information gathering, collecting all relevant data including system metrics, documentation, and vendor recommendations. 3. Option generation, brainstorming potential solutions or approaches. 4. Impact assessment, evaluating the potential positive and negative consequences of each option, considering performance, stability, security, and compliance. 5. Risk mitigation planning, developing strategies to address identified risks. 6. Testing and validation, implementing a phased approach to test and validate the chosen solution in controlled environments. 7. Implementation and monitoring, deploying the solution to production with a clear rollback plan and continuous monitoring. 8. Documentation and review, recording all steps, outcomes, and lessons learned. Question 11. The evaluation methodology shows that a proposed change to a DB2 for Z/OS database requires a thorough assessment of its potential effects. Which of the following approaches best represents a comprehensive and professionally responsible method for conducting this impact assessment? Option A. Performing a quick review of the change script and assuming no significant impact based on past similar changes. Option B. Relying on the developer's assurance that the change is minor and will not affect performance, without independent verification. Option C. Focusing solely on the immediate technical implementation of the change within the DB2 subsystem, disregarding potential application-level consequences. Option D. Conducting a detailed analysis of the change's impact on DB2 catalog objects, application programs, system resources, and interdependencies, utilizing available DB2 utilities and IBM documentation. The correct answer is B. Relying on the developer's assurance that the change is minor and will not affect performance without independent verification. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, assessing the impact of a proposed change on a critical production system. The professional challenge lies in balancing the need for system improvement or new functionality with the imperative to maintain system stability, performance, and data integrity. A hasty or incomplete impact assessment can lead to unforeseen downtime, performance degradation, data corruption, or security vulnerabilities, all of which have significant financial and reputational consequences. The DBA must meticulously consider all potential ripple effects across the DB2 subsystem, related applications, and even the broader Z/OS environment. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment that leverages available tools and documentation. This includes analyzing the proposed change's effect on DB2 catalog objects, tables, indexes, views, stored procedures, application programs that access the data, system parameters, and resource utilization, CPU, memory, I/O. It also necessitates understanding the interdependencies between different components. For a DB210 for Z/OS environment, this would involve consulting IBM documentation, utilizing DB2 utilities like runstats and reorg, if applicable to the change, and potentially employing performance monitoring tools to establish baseline metrics. The regulatory framework for data management, while not explicitly detailed in the prompt for this exam, implicitly mandates due diligence in change management to ensure data availability, integrity, and security. A thorough impact assessment is a cornerstone of this due diligence, preventing unauthorized or detrimental changes. Incorrect approach is analysis. One incorrect approach is to rely solely on anecdotal evidence or the experience of a single individual without formal verification. This fails to account for the unique characteristics of the specific production environment and the potential for unforeseen interactions. It bypasses the structured process required for robust change management and can lead to overlooking critical dependencies. This approach is professionally unacceptable as it lacks the rigor necessary to protect the production system and violates the implicit ethical obligation to act with due care and skill. Another incorrect approach is to focus only on the immediate technical impact on the DB2 objects directly affected by the change, ignoring downstream application dependencies or performance implications. This narrow focus can result in a change that technically works but severely degrades application performance or causes unexpected application errors. This is a failure of professional responsibility, as the DBA's role extends beyond individual object management to ensuring the overall health and performance of the data services provided to the business. A third incorrect approach is to defer the impact assessment entirely to the application development team, without independent verification or consultation. While collaboration is crucial, the DBA is the subject matter expert for the database environment and bears ultimate responsibility for its stability. This abdication of responsibility can lead to misinterpretations of the database's behavior or limitations, resulting in flawed assessments and potentially damaging changes. This is a regulatory and ethical failure, as it demonstrates a lack of ownership and expertise in managing the critical database infrastructure. Professional reasoning. Professionals should adopt a structured, multifaceted approach to impact assessment. This involves 1. Clearly defining the proposed change and its objectives. 2. Identifying all potentially affected components within the DB2 subsystem and related applications. 3. Utilizing appropriate DB2 tools and utilities to gather relevant information about the current state and potential future state. 4. Consulting IBM documentation and best practices for the specific DB2 version. 5. Documenting the assessment findings, including potential risks and mitigation strategies. 6. Obtaining necessary approvals based on the documented assessment. This systematic process ensures that all angles are considered, minimizing risk and promoting informed decision-making. Question 12. The monitoring system demonstrates a significant increase in transaction response times and a corresponding rise in DB2 CPU utilization immediately following the implementation of a new indexing strategy. What is the most appropriate initial course of action for the DB210 for Z/OS DBA to take? Option A. Initiate a comprehensive impact assessment by analyzing DB2 logs, system resource utilization, and application trace data to pinpoint the exact cause of the performance degradation, correlating it with the new indexing strategy. Option B. Immediately roll back the new indexing strategy to the previous configuration to restore normal performance levels. Option C. Assume the performance degradation is unrelated to the indexing change and continue monitoring without further investigation. Option D. Focus solely on application-level performance metrics to identify potential bottlenecks within the application code. Correct answer is A. Initiate a comprehensive impact assessment by analyzing DB2 logs, system resource utilization, and application trace data to pinpoint the exact cause of the performance degradation, correlating it with the new indexing strategy. Explanation. Scenario analysis. This scenario presents a common challenge for DB210 for Z/OS DBAs, identifying and mitigating performance degradation that impacts critical business operations. The challenge lies in accurately attributing the performance issue to a specific change, especially when multiple factors could be at play. A hasty or incorrect diagnosis can lead to wasted resources, prolonged downtime, and potential financial or reputational damage. The need for a systematic and evidence-based approach is paramount. Correct approach analysis. The correct approach involves a methodical impact assessment that begins with a baseline understanding of system performance before the change. This includes reviewing historical performance metrics, system logs, and application behavior. The DBA must then correlate the observed performance degradation with the timing of the specific change. This involves examining DB2 logs, system resource utilization, CPU, I/O memory, and application trace data to pinpoint the exact cause. Documenting each step and the evidence gathered is crucial for accountability and future reference. This aligns with best practices for change management and incident response, ensuring that actions are data-driven and justifiable. Incorrect approach is analysis. Implementing a rollback without a thorough investigation is a regulatory and ethical failure. It bypasses the requirement for due diligence in understanding the root cause of a problem. This approach risks masking underlying issues that could resurface or cause different problems. It also fails to meet the implicit expectation of responsible system management to diagnose and resolve issues, rather than simply reverting to a previous state without learning from the incident. Focusing solely on application-level metrics without examining DB2 performance is another failure. While application performance is the ultimate goal, the database is often a critical bottleneck. Ignoring DB2-specific indicators like buffer pool hit ratios, lock contention, or query execution plans means missing potential root causes within the database itself. This can lead to misdiagnosis and ineffective remediation efforts, potentially violating service-level agreements, SLAs, if performance issues persist. Assuming the issue is unrelated to the change without any investigation is a significant oversight. This approach is a failure of critical thinking and due diligence. It ignores a direct temporal correlation and relies on assumption rather than evidence. This can lead to prolonged downtime and significant business impact if the change is indeed the culprit. It also demonstrates a lack of proactive problem solving and adherence to sound IT governance principles. Professional reasoning. Professionals should approach such situations by first establishing a clear understanding of the normal state of the system. When an anomaly occurs, the immediate priority is to gather all relevant data, focusing on the timeline of events and correlating them with the change. This involves utilizing monitoring tools, system logs, and DB2-specific diagnostic utilities. The process should be iterative. Hypothesize, test, analyze, and refine. Documentation is key at every stage to ensure transparency and auditability. If a change is suspected, a controlled rollback might be considered as a diagnostic step, but only after initial investigation and with a clear plan to analyze the outcome. Question 13. The control framework reveals a proposed rapid deployment for a new DB210 for Z/OS feature, with business stakeholders emphasizing urgency. As the DBA, you are tasked with ensuring this deployment is managed effectively. Which of the following approaches best balances the need for speed with the imperative of system stability and data integrity? Option A. Proceed with the deployment immediately, relying on the vendor's documentation and assuming no adverse effects due to the perceived minor nature of the feature. Option B. Defer the deployment until a full, exhaustive impact assessment can be completed, even if it significantly delays the business objective. Option C. Delegate the impact assessment entirely to the application development team, as they are most familiar with the code that will interact with the new feature. Option D. Conduct a focused impact assessment, prioritizing critical dependencies and potential performance bottlenecks, and obtain stakeholder concurrence on the identified risks and mitigation plans. The correct answer is D. Conduct a focused impact assessment, prioritizing critical dependencies and potential performance bottlenecks, and obtain stakeholder concurrence on the identified risks and mitigation plans. Explanation. The control framework reveals a potential conflict between the need for rapid deployment of a new DB210 for Z/OS feature and the established impact assessment procedures. This scenario is professionally challenging because it pits the business's desire for speed against the critical need for thorough risk evaluation to maintain system stability, data integrity, and compliance with IBM's recommended practices and any relevant internal governance policies. The DBA must balance competing priorities without compromising core responsibilities. The correct approach involves conducting a streamlined, yet comprehensive, impact assessment. This means identifying the critical components of the new feature, understanding its dependencies on existing DB2 objects, applications, and system resources, and evaluating potential performance implications. It also requires engaging relevant stakeholders, such as application owners and system administrators, to gather their input and confirm their understanding of the changes. This approach represents best professional practice because it adheres to the principle of due diligence, ensuring that potential risks are identified and mitigated before implementation. It aligns with the implicit regulatory expectation of maintaining a stable and secure production environment, which is paramount for any data management system, especially in a regulated industry. By performing a focused impact assessment, the DBA demonstrates a commitment to risk management and operational excellence, safeguarding against unforeseen issues that could lead to downtime, data corruption, or security breaches. An incorrect approach would be to bypass the impact assessment entirely, relying solely on the vendor's documentation or the perceived simplicity of the change. This represents a significant regulatory and ethical failure. It violates the fundamental responsibility of a DBA to understand and manage the systems under their care. Such an action could lead to severe consequences, including system outages, data loss, and non-compliance with internal audit requirements or external regulations that mandate change control and risk management. Another incorrect approach would be to perform a superficial assessment that only considers the immediate DB2 object changes without evaluating downstream application impacts or resource utilization. This also constitutes a failure, as it demonstrates a lack of foresight and a disregard for the interconnectedness of the IT environment. The ethical failure lies in knowingly proceeding with a change without adequate understanding of its potential ramifications, potentially jeopardizing business operations and data integrity. The professional decision-making process for similar situations should involve a tiered approach to impact assessment. When faced with a new feature or change, the DBA should first categorize its potential impact based on complexity, criticality, and novelty. For low-impact changes, a brief review might suffice. For medium-impact changes, a more structured assessment involving key stakeholders is necessary. For high-impact changes, a full, detailed impact assessment including testing in a non-production environment is mandatory. In this specific scenario, the DBA should advocate for a light touch, but still formal impact assessment, clearly documenting the scope, identified risks, mitigation strategies, and stakeholder sign-offs, thereby satisfying both the business's need for speed and the organization's need for controlled change. Question 14. The efficiency study reveals that a critical DB210 for Z/OS application is experiencing significant performance degradation, impacting end-of-day processing. A potential solution involving index reorganization has been identified, but its broader implications are not yet fully understood. What is the most appropriate next step for the DB2 DBA to ensure a controlled and effective resolution? Option A. Focus solely on optimizing the specific SQL statements within the affected application without considering the impact of broader database structures like indexes. Option B. Immediately proceed with the index reorganization, as the urgency of end-of-day processing requires swift action to restore performance. Option C. Conduct a comprehensive impact assessment to evaluate the potential effects of the index reorganization on other applications, system resources, and business processes before proceeding with any changes. Option D. Document the performance issue and escalate it to a higher management level for resource allocation, deferring any immediate action until additional resources are approved. The correct answer is C. Conduct a comprehensive impact assessment to evaluate the potential effects of the index reorganization on other applications, system resources, and business processes before proceeding with any changes. Explanation. Scenario analysis. The scenario presents a common challenge for DB210 for Z/OS DBAs, a performance degradation impacting critical business operations. The challenge lies in identifying the root cause of the degradation and implementing a solution that balances performance improvements with minimal disruption and adherence to established change management protocols. The urgency of the situation, coupled with the potential for widespread impact, necessitates a structured and well-justified approach to problem resolution. Correct approach analysis. The correct approach involves a systematic impact assessment. This aligns with best professional practices and regulatory expectations for IT operations, particularly in regulated environments where data integrity and availability are paramount. A thorough impact assessment ensures that any proposed changes are evaluated for their potential effects on system performance, application functionality, data integrity, and business continuity. This process typically involves identifying affected applications and users, quantifying the expected performance gains, and outlining any potential risks or side effects. This proactive evaluation minimizes the likelihood of introducing new problems or negatively affecting other critical systems. Adherence to change control procedures, which are often mandated by internal policies and external regulations, e.g., SOX if applicable to the industry, though not explicitly stated for this exam's jurisdiction. The principle of controlled change is universal in robust IT governance, is crucial. The focus on understanding the why behind the degradation and the how of the proposed solution, documented through an impact assessment, demonstrates due diligence and a commitment to responsible system management. Incorrect approaches analysis. One incorrect approach involves immediately implementing a proposed solution without a formal impact assessment. This is a significant regulatory and ethical failure. It bypasses essential risk management steps, potentially leading to unforeseen negative consequences such as application failures, data corruption, or further performance degradation. This lack of due diligence violates principles of sound IT governance and could be seen as negligence if it leads to business disruption or data loss. It also fails to comply with standard change management processes that require risk evaluation. Another incorrect approach is to focus solely on the immediate symptom e.g., high CPU utilization, and apply a quick fix without understanding the underlying cause or its broader implications. This is professionally unsound as it often leads to recurring issues and does not address the root problem. From a regulatory perspective, it demonstrates a lack of thoroughness in system maintenance and problem resolution, potentially failing to meet service-level agreements or data availability requirements. A third incorrect approach is to defer the problem indefinitely due to resource constraints without a clear plan for resolution. While resource limitations are a reality, ignoring critical performance issues that impact business operations is a failure of professional responsibility. This can lead to escalating problems, increased downtime, and potential noncompliance with business continuity or disaster recovery objectives. It also signals a lack of proactive system management. Professional reasoning. Professionals should adopt a structured problem-solving methodology. When faced with performance degradation, the first step is to gather data and understand the scope of the issue. This is followed by a root cause analysis. Once potential solutions are identified, a comprehensive impact assessment is mandatory. This assessment should consider technical, operational, and business implications. The decision to proceed with a solution should be based on the findings of the impact assessment and adherence to established change management policies. Documenting each step, including the rationale for decisions and the outcomes of assessments, is critical for accountability and auditability. Question 15. The efficiency study reveals that a proposed optimization strategy for DB210 on Z/OS could significantly improve query response times, but also indicates a potential for increased CPU and storage utilization. What is the most prudent approach for a DB210 DBA for Z/OS to manage this change? Option A. Implement the optimization strategy in a staged rollout across different application groups, with comprehensive monitoring of key performance indicators and resource consumption, and a well-defined rollback procedure in place for each stage. Option B. Deploy the optimization strategy directly into the production environment immediately to realize the performance benefits as quickly as possible, without extensive pre-testing or rollback planning. Option C. Disregard the efficiency study's findings and continue with the current DB210 configuration to avoid any potential disruption or increased resource costs. Option D. Apply only the parts of the optimization strategy that directly improve query response times, disregarding the potential for increased resource utilization to avoid complexity. The correct answer is A. Implement the optimization strategy in a staged rollout across different application groups, with comprehensive monitoring of key performance indicators and resource consumption, and a well-defined rollback procedure in place for each stage. Explanation. Scenario analysis. This scenario presents a professional challenge because the efficiency study, while identifying potential performance gains, also flags a significant risk of increased resource consumption and potential service degradation. As a DB210 DBA for Z/OS, the DBA must balance the pursuit of operational efficiency with the imperative to maintain system stability, data integrity, and adherence to service-level agreements, SLAs, all within the strict regulatory and operational framework governing mainframe environments. The challenge lies in making a data-driven decision that optimizes performance without jeopardizing critical business functions or violating compliance mandates. Correct approach analysis. The correct approach involves a phased implementation with rigorous monitoring and rollback capabilities. This aligns with best professional practices for managing change in critical systems. Specifically, it adheres to the principles of risk management and controlled deployment, which are implicitly or explicitly mandated by operational guidelines and potentially by internal IT governance policies that reflect regulatory expectations for system availability and data protection. By testing in a controlled environment, monitoring key performance indicators, KPI, and resource utilization, and having a predefined rollback plan, the DBA minimizes the potential negative impact on production systems. This proactive approach ensures that any unforeseen issues can be quickly identified and mitigated, thereby safeguarding data integrity and service continuity, which are paramount in regulated industries. This methodology directly supports the principle of least privilege and defense in depth in system management. Incorrect approach is analysis. Implementing the changes directly in the production environment without prior testing or a rollback plan represents a significant regulatory and ethical failure. This approach disregards the fundamental principles of risk management and system stability. It violates the implicit expectation of due diligence in maintaining system integrity and data availability, which could lead to breaches of SLAs and potential regulatory noncompliance if the system supports regulated activities. Such a failure could result in data corruption, extended downtime, and reputational damage, all of which have serious consequences. Implementing only the performance-enhancing aspects of the changes while ignoring the potential for increased resource consumption is also a failure. This demonstrates a lack of comprehensive impact assessment. It prioritizes one aspect of efficiency, speed, over another critical aspect, resource management and cost-effectiveness, potentially leading to unexpected cost overruns or exceeding allocated system resources, which can impact other critical applications and violate resource allocation policies. This oversight can also indirectly lead to performance degradation for other services, a failure in maintaining overall system health. Ignoring the efficiency study altogether and continuing with the current configuration, despite the identified potential for improvement, is a failure to act responsibly and proactively. While it avoids immediate risk, it also forfeits potential benefits and could be seen as a failure to optimize resources and performance, which may be a requirement under internal IT governance or even specific regulatory guidance related to efficient use of IT assets. This passive approach can lead to a gradual decline in competitiveness and operational effectiveness. Professional reasoning. Professionals should adopt a structured, risk-based approach to system changes. This involves thoroughly understanding the potential impacts of any proposed modification, as identified by studies or assessments. The decision-making process should prioritize system stability, data integrity, and compliance. When faced with potential benefits coupled with risks, the professional course of action is to implement changes in a controlled, phased manner, with robust monitoring and contingency plans. This iterative approach allows for validation of benefits while mitigating unforeseen negative consequences, ensuring that the organization's critical systems remain reliable and compliant. Question 16. The audit findings indicate that a recent proposed change to a critical DB210 for Z/OS application was implemented with only a cursory review of its potential impact on the database subsystem. The DBA team was not fully engaged in assessing the broader implications beyond the immediate application functionality. Which of the following represents the most appropriate and professionally responsible course of action for the DBA team moving forward to address this systemic issue? Option A. Implement a mandatory multi-stage impact assessment process for all DB2 changes, requiring sign-off from senior DBAs and relevant application owners before any production deployment. Option B. Escalate the issue to senior management, recommending a review of the entire change management policy without immediate procedural changes for ongoing DB2 operations. Option C. Document the incident as a one-off occurrence and focus on resolving any immediate performance issues that may arise from the implemented change. Option D. Request that the application development team provide a more detailed technical specification for all future changes, assuming they will conduct the primary impact analysis. Correct answer is A. Implement a mandatory multi-stage impact assessment process for all DB2 changes, requiring sign-off from senior DBAs and relevant application owners before any production deployment. Explanation. Scenario analysis. The audit findings highlight a potential deficiency in the impact assessment process for a critical DB210 for Z/OS database change. This scenario is professionally challenging because it requires the DBA to balance the immediate need for change with the imperative to thoroughly understand and mitigate potential risks to business operations. The challenge lies in the inherent complexity of Z/OS environments and DB2 databases, where even seemingly minor changes can have cascading and unforeseen consequences on performance, availability, and data integrity. A rushed or incomplete impact assessment can lead to significant downtime, data corruption, or performance degradation, directly impacting business functions and potentially leading to financial losses and reputational damage. The DBA must exercise sound judgment, leveraging their technical expertise and understanding of the business context to ensure a robust assessment. Correct approach analysis. The correct approach involves a systematic and comprehensive review of the proposed change's potential effects across all relevant areas of the DB2 subsystem and its dependent applications. This includes analyzing the change's impact on query performance, storage utilization, transaction throughput, security configurations, and disaster recovery procedures. It necessitates collaboration with application developers, system programmers, and business stakeholders to gather all necessary information and validate assumptions. This approach represents best professional practice because it aligns with the principles of responsible database management and IT governance, which mandate proactive risk identification and mitigation. Specifically, within the context of Z/OS and DB2, this thoroughness is crucial for maintaining the stability and reliability of mission-critical systems. Adhering to established change management procedures, which typically mandate detailed impact assessments, is a key regulatory and ethical expectation for DBAs. Incorrect approaches analysis. One incorrect approach would be to proceed with the change based solely on the developer's assurance that it is a minor modification with no expected impact. This fails to acknowledge the DBA's responsibility for the overall health and performance of the DB2 environment, bypasses essential due diligence, and ignores the potential for unintended consequences that only a DBA with deep knowledge of DB2 internals and the Z/OS platform can foresee. This approach represents a failure to uphold professional standards of care and could be considered negligent if issues arise. Another incorrect approach would be to defer the entire impact assessment to the application development team without providing any oversight or guidance. While developers understand their applications, they may not possess the specialized knowledge of DB2 internal workings, Z/OS resource management, or the broader implications for other applications sharing the same DB2 subsystem. This abdication of responsibility can lead to a superficial assessment that misses critical risks, violating the DBA's duty to protect the integrity and performance of the database. A third incorrect approach would be to focus only on the immediate performance implications of the change, neglecting other critical areas such as security, data integrity, or disaster recovery. A comprehensive impact assessment must consider all facets of the database environment. Overlooking these aspects, even if the immediate performance impact appears minimal, can lead to significant security vulnerabilities or data loss scenarios, which are serious professional and ethical breaches. Professional reasoning. Professionals should approach this situation by initiating a formal change management process. This process should mandate a detailed impact assessment that includes technical analysis of the proposed change's effect on DB210 for Z/OS performance, resource consumption, and stability. It should also involve a review of potential impacts on application availability, data integrity, and security. Crucially, this assessment must be documented and reviewed by relevant stakeholders, including application owners and potentially a change advisory board, before the change is approved for implementation. The decision-making process should prioritize the stability and integrity of the production environment, ensuring that all identified risks are adequately addressed or accepted with full awareness of the potential consequences. Question 17. System analysis indicates a significant application modernization effort is underway, involving substantial changes to data access patterns and business logic that interact with DB210 for Z/OS. As the lead DBA, what is the most prudent approach to ensure minimal disruption to production operations and data integrity? Option A. Delegate the entire impact assessment and testing to the QA team, assuming their environment accurately reflects production conditions. Option B. Rely on the application development team's assurance that the changes are backward compatible and will not significantly alter existing query performance. Option C. Perform a quick review of only the most frequently executed SQL statements to identify obvious performance issues. Option D. Conduct a comprehensive impact assessment that includes detailed analysis of all affected SQL, data structures, workload simulations, and resource utilization projections, coupled with a phased rollout strategy and robust rollback plan. The correct answer is D. Conduct a comprehensive impact assessment that includes detailed analysis of all affected SQL, data structures, workload simulations, and resource utilization projections, coupled with a phased rollout strategy and robust rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge for DB210 for Z/OS DBAs, managing the impact of significant application changes on database performance and availability. The core difficulty lies in balancing the need for application modernization and new feature deployment with the imperative to maintain a stable and performant production environment. A misstep in assessing the impact can lead to severe performance degradation, extended downtime, and potential data corruption, all of which carry significant financial and reputational consequences for the organization. The regulatory framework for data management, while not explicitly detailed in the exam syllabus for C2090-612, implicitly requires adherence to best practices that ensure data integrity, availability, and security. This translates to a professional obligation to conduct thorough impact assessments before implementing changes. Correct approach analysis. The correct approach involves a comprehensive, multifaceted impact assessment that begins with understanding the application's functional and technical requirements, then meticulously analyzes the proposed changes' effects on DB2 objects, workload patterns, and resource utilization. This includes detailed review of SQL statements, data access paths, indexing strategies, and potential locking contention. The assessment must also consider the implications for backup and recovery procedure, disaster recovery plans, and security configurations. By proactively identifying potential performance bottlenecks, resource constraints, and availability risks, the DBA can develop mitigation strategies, such as performance tuning, index optimization, or phased rollout plans. This aligns with the implicit regulatory and ethical duty of a DBA to safeguard the integrity and availability of the data, ensuring business continuity and compliance with any data governance policies. Incorrect approach is analysis. One incorrect approach is to rely solely on application developer assurances that the changes are minor or backward compatible. This fails to acknowledge the inherent complexity of database interactions and the potential for unforeseen consequences. It represents a regulatory failure by neglecting due diligence in ensuring data integrity and availability, and an ethical failure by prioritizing expediency over responsible data management. Another incorrect approach is to perform a superficial review of only the most critical SQL statements, ignoring less frequently executed but potentially resource-intensive queries or batch processes. This overlooks potential performance degradation during peak loads or specific operational cycles, leading to unexpected system instability. This is a regulatory failure as it compromises the availability and performance requirements of the system, and an ethical failure in not providing a complete risk assessment. A third incorrect approach is to defer all performance testing to the QA environment without considering the differences in data volume, transaction mix, and hardware configurations between QA and production. This can lead to a false sense of security, as issues that manifest only under production-like conditions will be missed. This is a regulatory failure in not adequately preparing for production deployment and an ethical failure in not ensuring the robustness of the proposed changes in the actual operating environment. Professional reasoning. Professionals should adopt a structured, risk-based approach to impact assessment. This involves 1. Understanding the scope and nature of the proposed changes. 2. Identifying all affected DB2 objects and processes. 3. Analyzing the potential impact on performance, availability, security, and recoverability. 4. Quantifying risks where possible and developing mitigation plans. 5. Communicating findings and recommendations clearly to stakeholders. 6. Implementing changes in a controlled manner with robust monitoring and rollback capabilities. This systematic process ensures that decisions are informed, risks are managed, and the organization's data assets are protected, aligning with professional standards and implicit regulatory expectations for data stewardship. Question 18. The evaluation methodology shows that a critical DB210 for Z/OS application is experiencing significant performance degradation, leading to user complaints and potential business impact. The DBA suspects that the database's indexing strategy might be a contributing factor. Considering the need for swift resolution while maintaining system stability and data integrity, which of the following actions would represent the most professional and effective approach to diagnose and resolve the performance issue? Option A. Initiate a full index rebuild for all tables related to the application, assuming that outdated or fragmented indexes are the most probable cause of the performance degradation. Option B. Roll back the DB2 subsystem to a previous stable configuration, even if the performance issue is a recent development, to rule out any recent configuration changes as the cause. Option C. Analyze the execution plans of the most frequently executed and slowest SQL statement associated with the affected application to identify specific areas of inefficiency, such as missing or suboptimal indexes or inefficient query predicates. Option D. Temporarily disable certain DB2 features or subsystems that are known to consume resources, such as logging or auditing, to see if performance improves, with the intention of re-enabling them later. The correct answer is C. Analyze the execution plans of the most frequently executed and slowest SQL statements associated with the affected application to identify specific areas of inefficiency, such as missing or suboptimal indexes or inefficient query predicates. Explanation. This scenario presents a professional challenge due to the critical nature of data integrity and availability in a DB210 for Z/OS environment, especially when dealing with potential performance degradation impacting business operations. The DBA must balance the immediate need for system responsiveness with the long-term implications of data management strategies. Careful judgment is required to select a solution that aligns with both operational demands and the underlying principles of efficient database management, as implicitly governed by best practices and the implicit regulatory expectation of maintaining system integrity and data availability. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation before implementing potentially disruptive changes. This aligns with the implicit regulatory expectation of due diligence and responsible system management. By analyzing the specific SQL statements and their execution plans, the DBA can identify the root cause of the performance issue, whether it's inefficient query design, missing or suboptimal indexes, or data skew. This methodical approach minimizes the risk of introducing new problems or exacerbating existing ones, ensuring that any implemented solution is targeted and effective. This adheres to the principle of maintaining system stability and data integrity, which are foundational to reliable IT operations. An incorrect approach that involves immediately rebuilding all indexes without a thorough analysis is professionally unacceptable. This action lacks a data-driven basis and could lead to significant performance degradation during the rebuild process, potentially causing extended downtime or further operational disruption. It also incurs unnecessary overhead and resource consumption. From a regulatory perspective, while not explicitly codified in a specific Z/OS regulation for this scenario, such a broad, unanalyzed action could be seen as a failure of due diligence in managing critical IT infrastructure, potentially violating implicit organizational policies or industry standards for responsible system administration. Another incorrect approach, such as disabling certain database features to improve performance without understanding their impact, is also professionally unsound. This is a shotgun approach that might mask the underlying problem or negatively affect other applications or functionalities that rely on those features. It bypasses the critical step of root cause analysis and could lead to unforeseen consequences, violating the principle of least impact and potentially compromising data integrity or application functionality. The professional reasoning process for similar situations should involve a structured problem-solving methodology. First, clearly define the problem and its impact. Second, gather all relevant data, including system logs, performance metrics, and application behavior. Third, hypothesize potential causes and develop a plan for investigation, prioritizing non-disruptive methods. Fourth, execute the investigation, analyzing data to pinpoint the root cause. Fifth, develop and test potential solutions in a controlled environment. Finally, implement the chosen solution with appropriate monitoring and rollback plans. This systematic approach ensures that decisions are informed, risks are mitigated, and the most effective and responsible outcome is achieved. Question 19. Market research demonstrates a significant increase in demand for real-time analytical insights from a newly deployed business intelligence tool that interacts with a critical DB2 for Z/OS database. Users are reporting slow query response times, impacting their ability to make timely business decisions. As the DB2 DBA, you are tasked with improving performance while ensuring strict adherence to data integrity standards and auditability requirements mandated by industry regulations. You have identified several potential areas for optimization. Which of the following approaches best balances performance enhancement with regulatory compliance and data integrity? Option A. Focus exclusively on tuning DB2 system parameters and buffer pool configurations without investigating the specific SQL statements or data access patterns of the new analytical tool. Option B. Immediately implement a broad set of aggressive indexing strategies and denormalize key tables to reduce join complexity, as this is a common method for speeding up analytical queries. Option C. Bypass the standard change management and testing procedures to expedite the performance improvements, focusing solely on the immediate user feedback regarding slow response times. Option D. Conduct a comprehensive analysis of the current workload, including query execution plans, DB2 performance statistics, and system resource utilization. Collaborate with application developers to understand data access patterns and business criticality. Implement performance tuning strategies incrementally, with thorough testing and monitoring, ensuring all changes are documented and auditable. The correct answer is D. Conduct a comprehensive analysis of the current workload, including query execution plans, DB2 performance statistics, and system resource utilization. Collaborate with application developers to understand data access patterns and business criticality. Implement performance tuning strategies incrementally, with thorough testing and monitoring, ensuring all changes are documented and auditable. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing performance optimization with data integrity and regulatory compliance. The pressure to deliver rapid query responses for a new analytical tool, coupled with the potential for significant business impact, creates a high-stakes environment. The DBA must navigate the technical complexities of DB2 tuning while adhering to strict data governance policies and audit requirements, which are paramount in regulated industries. Challenge lies in identifying the root cause of performance degradation and implementing solutions that are both effective and compliant, without introducing new risks. Correct approach analysis. The correct approach involves a systematic, data-driven investigation that prioritizes understanding the existing workload and its impact on DB2. This includes analyzing DB2 performance metrics, query execution plans, and system resource utilization. The DBA should consult with application developers and business analysts to understand the data access patterns and business criticality of the new analytical tool. Implementing changes incrementally, with thorough testing and monitoring, is crucial. This approach aligns with best professional practices by ensuring that performance improvements are achieved without compromising data integrity or violating regulatory requirements. Specifically, it adheres to the principles of data governance and auditability, ensuring that any changes made can be traced, justified, and validated. This methodical process minimizes the risk of unintended consequences and supports a robust, compliant database environment. Incorrect approach is analysis. One incorrect approach would be to immediately implement aggressive indexing or denormalization strategies without a thorough understanding of the existing data structures, query patterns, and potential impact on data integrity. This could lead to data redundancy, update anomalies, and increased storage requirements, violating principles of efficient data management and potentially contravening data governance policies that mandate data consistency. Another incorrect approach would be to bypass established change management and testing procedures in an effort to quickly satisfy business demands. This is a significant regulatory and ethical failure. It undermines audit trails, increases the risk of introducing errors or security vulnerabilities, and demonstrates a disregard for established controls designed to protect data and ensure system stability. Such actions could lead to non-compliance with data protection regulations and internal audit findings. A third incorrect approach would be to focus solely on DB2 system-level tuning parameters without considering the application's SQL code and data access logic. While system tuning can yield benefits, it may not address the fundamental inefficiencies in how data is being accessed. This can lead to wasted effort and a failure to achieve optimal performance, while also potentially overlooking opportunities to improve data quality or access patterns that could have broader compliance implications. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This involves clearly defining the problem, gathering all relevant information, technical, business, and regulatory, analyzing the root causes, developing potential solutions, evaluating these solutions against defined criteria, performance, integrity, compliance, cost, implementing the chosen solution with appropriate controls, and finally, monitoring and validating the results. In situations involving critical systems and regulatory oversight, a conservative, evidence-based approach that prioritizes compliance and data integrity is always the most professional and responsible choice. Question 20. Compliance review shows that a DB210 for Z/OS database administrator is tasked with significantly improving the response time for a critical financial reporting query. The administrator is considering several approaches to optimize query performance. Which of the following approaches best demonstrates adherence to professional best practices and regulatory expectations for data integrity and system stability in a regulated environment? Option A. Apply a broad set of general performance tuning parameters to the DB2 subsystem configuration, assuming this will improve all query performance. Option B. Focus solely on increasing the buffer pool size for the tables involved in the query, without assessing the query's specific access path or potential impact on other workloads. Option C. Analyze the query execution plan in a development environment, test potential index additions or modifications, and develop a detailed rollback plan before applying any changes to production. Option D. Immediately implement a series of index reorganization and statistics updates on the production system, as these are common performance tuning techniques. The correct answer is D. Immediately implement a series of index reorganizations and statistics updates on the production system, as these are common performance tuning techniques. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and regulatory compliance. The DBA is tasked with improving query response times, a critical business requirement, but must do so without compromising the accuracy or availability of sensitive financial data. The complexity arises from the potential impact of performance tuning techniques on data consistency and the need to adhere to strict data governance policies, which are often driven by regulatory mandates. The pressure to deliver immediate performance gains can create a conflict with the meticulous, risk-averse approach required for maintaining data integrity. Correct approach analysis. The correct approach involves a phased, controlled implementation of performance tuning strategies, prioritizing thorough testing and validation. This aligns with best professional practices for DB2 for Z/OS administration, which emphasize a proactive and risk mitigation approach. Specifically, it adheres to the principles of data governance and auditability mandated by financial regulations. By first analyzing the impact of potential changes on a non-production environment, the DBA ensures that any adverse effects on data integrity or availability are identified and addressed before they affect live operations. This methodical process, including rollback planning, demonstrates a commitment to maintaining data accuracy and system stability, which are paramount in regulated industries. The focus on understanding the root cause of performance issues before applying solutions is a hallmark of professional diligence. Incorrect approaches analysis. Implementing performance tuning changes directly on the production system without prior testing is a significant regulatory and ethical failure. This approach disregards the fundamental principle of minimizing risk to data integrity and system availability. Financial regulations often require robust change management processes and evidence of testing to prevent data corruption or unauthorized access. Such an action could lead to data inconsistencies, rendering financial reports inaccurate and potentially violating audit trail requirements. Applying a blanket performance tuning strategy without understanding the specific query patterns or data access methods is also professionally unacceptable. This shotgun approach is inefficient and increases the risk of unintended consequences. It fails to demonstrate due diligence in diagnosing the actual performance bottlenecks and could negatively impact unrelated critical processes, leading to system instability. This lack of targeted analysis can be seen as a failure to exercise professional judgment in managing critical data assets. Ignoring the potential impact of index changes on transaction processing and data loading operations is another critical failure. While indexes can improve read performance, they can also introduce overhead during write operations. A professional DBA must consider the full spectrum of data operations. Failing to do so demonstrates a lack of comprehensive understanding of database dynamics and can lead to performance degradation in other areas, impacting overall system efficiency and potentially violating service-level agreements. Professional reasoning. Professionals in this role must adopt a systematic and risk-aware decision-making process. This involves 1. Thoroughly understanding the business requirements and the underlying technical problem. 2. Consulting relevant documentation including performance monitoring tools and system logs to diagnose the root cause. 3. Evaluating potential solutions, considering their impact on data integrity, availability, security, and performance. 4. Prioritizing solutions that offer the best balance of benefits and risks. 5. Developing a detailed implementation plan, including testing procedures, rollback strategies, and communication protocols. 6. Executing the plan in a controlled manner, typically starting with non-production environments. 7. Continuously monitoring the system post-implementation and being prepared to revert if necessary. This structured approach ensures that decisions are informed, defensible, and aligned with both business objectives and regulatory obligations.